All right, good evening, everyone, and Royal Grand Engineering Trainees and the Nigerian Society of Engineers Abeokuta branch welcomes you to this training on Protastructure. Today is the day 3 of the 1 month free training that is being organized by REnT and NSE Abeokuta. Okay, so what we have done in our previous class, we have now successfully learned how to model our buildings, how to create our column members, our beams, our slabs, how to create slab openings, how to create axes, and how to relabel our members, and how to superimpose our structure, that is creating multiple stories. Okay, so in our today's class, what we are going to be looking at is analysis, design, and then we can now move to our part 15. After that, quickly we are going to be taking some drawing some conclusions and then taking some questions. Okay, so if you did your assignments, this is what you're going to get, assuming you have done your assignments in the second after the second training. So what you are going to get is going to look like this. Your model is meant to look like this. Okay, so we are going to be moving from here, and today is the day 3 of the training. So today we are going to be talking about the pre-analysis, then materials and loadings. Then we are going to talk about the building analysis, finite element models and displacement diagrams, design and interactive design checks, pad foundation design, and then we are going to draw conclusions. Okay. So at the end of this training, what I expect everyone who participated in this day's session, you are expected to learn the following. You are expected to learn how to perform building analysis of RC structures, perform interactive design checks for RC members, and design path foundation, basically. So we are expected to know the basics of all this. Okay, so we are going to be covering all these things in depth during advanced classes, by the way, but you are expected to know the basics about all this. Okay, so now let's now jump straight into what we have today. Okay, so now when you have now finished modeling your building, the next thing you need to do is to run analysis. Okay, so when you have now gotten to the stage where you have modeled all your members, all your beams, your cantilever slabs, your cantilever beams, how you want your members to look, although we didn't model cantilever beams and slabs, but after modeling, the next thing that follows suit is your analysis, then design. Okay, but before we jump straight into that, what I would like us to do, I would like us to go through something that we should have done. Something that I want us to know, okay, when it comes to Protastructure. Okay, so let's go to story. Go to your building status tab. Okay, your building status tab at the extreme right, you're going to find this option that says story operations. Click on it once, and then let's now review how we can now edit stories. I'm going to find that option that says edit story. So in the edit story dialog, you're going to get this dialog. So you're going to find the different settings that you can be able to make for our stories. You are going to notice that by default, our different story heights is 3 meters. So all the stories is by default set to 3 meters. You can observe that in the structure 3 by the left side of your screen. Okay, so you can see the story 0 is plus or minus 0.0 millimeters, story 1 3 meters, story 2 6 meters, and 9. So which means the default story for the different levels, the default story height for the different stories is 3 meters. So here is where you get the option to set all that if you want to change that. Okay, so here we have the story information, just simply not that important, but you need to keep that checked. So the story here is simply just the number, so it by default follows this sequential order. Okay, so here we have here the story height. This is where you get the option to change the height of your story. For instance, we have here story 1, story 2, and story 3. The height of story 1 is 3000 millimeters, I can choose to change that to 3,200 or 3,006 or 4,000, depending on what you have on the architectural design, depending on what you have by design. Okay, so you have to input, make sure that your model looks exactly as it should be in the design, that is in real life. Okay, so let me assume 3,115 millimeters for the sake of this class. So I'm going to do the same for all the stories. I say 3,150 millimeters. And the next column here, we have the level. So this is basically the reference level of that particular story from the ground. So here we have 3,150, simply the reference level. And here we have the level. So the level is simply the that level that you see when you are now watching at a when you are now looking at a particular column level, for instance. So you see something like 1:1. So that's one, which is the prefix before the C. This is where you have the option to change it. You can change it to any letter. You can call that ST1, which means story 1 column, or you can just leave it how it's set, or you can add anything. So the same thing goes for the story 2 and story 3. You can change all that. Okay, I choose to leave that as default. And here is just the description. This is basically to provide additional information about that particular story if you want. So it is not that important. It's just a description. It can be sentences or anything at all. So going to the left, we have this option that says structural system. Okay, so here you get the option to change the structural system that that particular story is made up of. So what we model is reinforced concrete, which is ROC. So if you click on that drop down arrow, you get the option to change it to either steel or any other material. Okay, we basically have ROC and steel here. So we are going to leave it as ROC. Okay, so at the bottom left side of this edit story dialog around this region. Okay, so you get this option that says effective top story number, which is 3. So I can change that to, the reason is because I can change that to because 2 is the effective number of story, because what we are designing for is a 2-story building. So it has 3 here because remember I said because of the roof level, it's always counted as a story in Protastructure. Okay, so here it says the first story. Okay, here we have this option that says first story bottom level. So the first story bottom level is simply the height or distance from the ordinary ground level to the, that is ordinary soil surface to the ground floor level. Okay, so you are going to notice that in every building, the actual ground level is not at the same level with the first floor, with the ground floor level. That is, it is not the same level with your ground floor level. That small distance between the ground floor level and the ordinary ground level, which is the soil level, is what we refer to as first story bottom level. Usually, in most cases, it can range between 400 millimeters and 600 millimeters, or any height depending on the design. So I will choose to leave it as 400 millimeters. Okay. So when I click OK, we are going to get
why that is okay now, but
so when I have this 400 millimeters, you're going to notice that the reference level of this particular story, which is the story 1, has changed to 3,550. That is, when you plus this 3,150 plus this 400, you're going to be getting 3,550. That is the actual reference level of this particular story, and the other reference levels follow suit. Okay, so I hope you understand this first story bottom level. If not, you can ask questions and you can still explain that in depth. So here you have the option that says foundation depth. Foundation depth is simply the depth of your foundation. Okay, so that is from the um story the zero level, ground zero level, that is the soil level or the ground level, downwards into the soil. That is the depth of the foundation or depth of the footing. So by default, we usually have that here as 1,100 millimeters. You can change that if you want. I choose to leave it as 1,100 millimeters. So here we have the footing level option, which is usually F. You can change that if you want. So that's basically what I want to show you with regards to this. Simply say. So when you have clicked OK, the your building model is going to update to that particular settings. Okay. So now let's now jump straight into what we have, which is the analysis and design. So, but before we do that, also we need to look at how to run a building model check for our design. That is when you have now finished modeling, you need to ensure that the connectivity of all your members, that no member is overlapping each other, and that you don't have any mistakes, or maybe from your axis is not properly aligned to the vertical or horizontal and all that. Okay. So to do that, simply go to your review tab over here. So you have loading, then you have review tab. So at the extreme left, that is the first option. You see this option that says building model check. Click on it once. So you're going to get this list of errors that is going to be checked. All of them: overlapping slab check, overlapping column check, and all that. Okay. So simply say start. When you have done that, just give it 5 seconds also. Okay. So you are going to get this option that says building model check completed. Number of errors will be equal to 0 if your model is perfectly arranged. Okay. So but here it says number of errors equal to 1. So that means I simply have to go back and look for that error, what caused that error. So here it says vertical axis d delta operation completed. To rectify this warning, please use fix the almost orthogonal axis function under the review bar. Okay, that explains itself. So whenever you encounter an error, you need to go back to your model and then make sure you correct that error before you are proceeding to your analysis. Okay, so let's close this and then let's fix that. So this is the option in the review tab, fix the almost orthogonal axis. So I'm getting this error because some of maybe one or two of my axes is not straight. Maybe it's inclined at a little angle to maybe it shifted the angle, the axis is a little bit diagonal. It's not very, very straight. Okay. So I'm going to correct that by using this option that says fix the almost orthogonal axis, or I can simply go one after the other and then check the properties of each axis and then make sure that the angle here is 0. So I can do that and now start correcting it from here one after the other, or I can simply go to the review tab and then say fix the almost orthogonal axis and then say okay, that is this axis. Say okay. So when I've done that, it is meant to be perfect. Now to run your analysis, okay, simply go to the analysis tab near the review tab and click on building analysis. Give that some time to open. Okay. So when you click on building analysis, the analysis options that you're going to see here. First of all, you're going to get pre-analysis, model options, analysis, post-analysis, and then reports. So the pre-analysis tab, this is where the basic assumptions of your buildings are made or of your design are made. Okay. So when you are designing for a building, most of you who are now reached at least 300 level in the university studying civil engineering, you should understand exactly what I'm saying. So design begins with some basic assumptions, the sizes of your columns. You have already done that. So the type of reinforcement, the properties of this reinforcement, the strength, the tensile strength, and the compressive strength of all that. Okay. So it is assumed from the beginning. Then subsequently, when you run your analysis and it's failing, then you can now increase or decrease it to as desired. Okay. So, but before we do that, let's now go into the project parameters. So click on settings center. Let's now perform a little bit of settings. So you're going to get here the codes, this option that says codes. When you click on that, you're going to see the different codes that you can use to design for your building. So you're going to click on this first one that says concrete design code. So by default, it's Eurocode. We actually selected that in the beginning to be Eurocode, United Kingdom Eurocode 2 for our concrete design. So that is the code that we use in Nigeria. So if this building is going to be built anywhere, any other place that is not Nigeria, you can find the design code that is stipulated for that region, okay? But in Nigeria, we use United Kingdom Eurocode. Select that and say, okay. It's already selected, I can just say cancel, okay? So here is the design code, still design code. You can click on that to change that, but since we have not modeled any steel members, we are not going to click on that. Here is your composite design code, loadings code, wind load code, and earthquake code for buildings that are going to be subjected to earthquake loadings and all that, okay? So here we have this option that says lateral drift and bracing. So this is actually in a way self-explanatory, okay? So this defines the bracing condition of your structure or of your building. So the columns or beams in direction 1, which is the horizontal directions, are going to be braced by columns and beams in direction 2. And likewise, same thing for the columns and beams in direction 2. They will be braced by columns and beams in direction 1. Okay, so that simply means that the members, your beam members, are going to be bracing themselves. Okay, so here we also have this way amplification coefficients. Okay, you have the option to change that automatically by clicking user defined. Okay, so but we are not going to be doing that. We are going to leave that as default. Okay. So go to this option that says units and format and change the displacement unit to millimeters so that we can be able to view the displacement values of our model or of our members in millimeters. Okay. So we have here that says project preferences. So just click on that. So here is where you get the basic design settings for your building for this particular project. So here you get the option to input the client name, the person you are designing this building for, and the project title, the date, address, revision number, and all that. And here you input the person that calculated it, drawn by, presented and designed by others. So it probably should be your name. Okay. So okay. So now when you're not done with all those settings, this is the basic settings that we need for now. Actually, you get the option to set your column design parameters, beam design parameters, the way they are going to be labeled, and the way the software is going to be choosing reinforcements or rebars for you. So we are not going to go into that for now. The basic settings that I've just done is the one that we are going to be needing right now. Okay. When you're done with that, simply say okay. Loading combinations, click on that. So we have actually generated our loading combinations. Okay, loading combinations are simply combinations, loading combinations that are used to ascertain the behavior of the building under the worst loading scenarios or under the worst case scenarios of loading. So it's going to combine wind load plus dead load, wind load plus live load, wind load plus notional load plus dead and live. So this combination is actually used according to how a particular design code is stipulated it for. Okay. So I don't expect you to alter any of this, but if you have not already generated your loadings, just simply click on loading generator. And when you have done that, don't alter or any of this, don't set anything here. Okay. So we are meant to be explaining all this and what you're going to set here during the advanced classes. Okay. And why we are setting it the way we are setting them. Okay. But for now, we are simply going to skip that, and then when you have now generated this loading, simply say okay. and then say okay. So here we have wind and story load. We are going to use these options. Click on these options to set for your um wind case parameters. But we are not going to do that because we are not going to be applying wind loading on this building. Reason is because before you apply wind loading on any building, there are certain considerations that needs to be taken into place. So we don't usually apply wind loading for any kind of building. This is simply a two-story building. It's not that a massive building. Okay, so we are not going to be applying that for now. So now let's finally move into our materials. So this is um simply this region here is shows you the materials and the properties of that. So you can see your columns here and the class of the concrete that will be used for your columns and the grade of steel or reinforcement for that. The same thing goes for the shear walls, beams and slab and all that. Okay. So now to set that, to change that, to change the properties of this, simply come here and say edit material. So when you have done that, you're going to find this option that says default material and foundation floor materials. So foundation floor materials are basically for your foundation elements alone. And here we have your default material is basically for your superstructure. That is for the rest of the structure. Okay. So we can change the class of concrete. We have here the class 25/30. Click on that. So when you click on that, you're going to find various grades of concrete or classes of concrete. Okay. So we have 16/20, 20/25, down to class 60/75. We are going to choose this class, which is C20/25. And here we are going to find the different properties of that particular class of concrete. Okay. So we have here the material name, the mechanical properties, the design parameters like the compressive strength of concrete, that is the FCK, knowing fully well that your concrete members are actually compressive, are very, very good in compression. That is your concrete. It's very good in compression, while your steel members is actually good for tensile. It's actually good for tensile, okay? So here you can find the different properties. You can add another one and then modify the mechanical and physical properties of that as well. I choose not to do that. So let's simply select this class 20/25 and then say okay. So let's do the same thing for shear walls. We have done for columns. So what you are going to do, let's select this class 20/25. So what you are going to do is that you are going to apply this particular class to each and every member that we have modeled. So it is advisable to make sure that each and every all your member is homogeneous. That is kind of monolithic, which means that all the class or the strengths, the properties of all the members, both the columns and the beams, are the same. Okay, so it goes a long way to ensure a good analysis and design. Okay, so to do that, simply click on this option that says apply to all members of this class in this story. Click on that then before you can now say okay. So you're going to notice that our concrete beams now have this option that says this particular grade of concrete. Okay, here is for your steel members. We have not modeled any steel members. We are not going to go into that for now. So we have the grade of concrete, the grade of steel here. So you can click that to change the grade of steel. So by default is 500. I'm going to leave it as 500. That is actually very reasonable. You can change it to 410, 460, as the case may be. Okay. So the FYK, which is the characteristic tensile strength of steel, is 500 Newton per millimeter squares. So we are going to leave that just like so. Then say okay. So when you have finished doing all that, just make sure you say okay, then move on. So when you are finished that, it simply means that you are finished with your pre-analysis. You have model options, then simply go to your analysis tab. We have already run our building model check, but in case you have not already done that, click on that and then click on start again, okay? So that your building model check will be repeated. Okay, click on close. Now, simply go and click building analysis. Then before that, you have this option that says perform eigenvalue analysis. This is actually used for seismic design purposes, and then display analytical model before option. If you check this option, the analytical model will be displayed before the actual analysis. Refresh connectivity information of all members. This is to refresh the connectivity information of all members. Okay, so here we have this option that says save foundation column / wall results for multi-block combined foundation design. Okay, so check this option. This option is required to be checked when your wall or your column members is actually going to be exported for maybe combined foundation designs and all that. So we are going to leave that unchecked for now. So simply say building analysis. Click on that once so that your analysis can start. And then you are going to, okay, let's wait for it 2 minutes. Can you still see my screen?
Yes, but just the wallpaper that's showing.
Okay, so I'm coming. Let me take care of it. I'm sorry for the delays. I'm working on something. I need to get the software back. Okay, all right. Can you all still hear me? Please indicate if you can hear me or send a message in the chat.
Yeah.
Yeah, we can hear you.
Okay, that's nice. We are back. Let me share my screen. Okay. All right, so this is where we are. Um, After you have finished doing your basic setting and building model check, simply click on building analysis. When you have clicked on that, you're going to get this design options that allows the software to begin the design immediately after the analysis. I'm going to check that so that the design can be run simultaneously immediately after the analysis rather. Okay, so check this one as well. So the reason is because the reason I'm checking this because we may not be having the time to go through the analysis differently and then the design options differently. Okay, so I'm going to check that so that it can be done. Can you all still hear me?
We can hear you. Can hear you.
Okay. Now simply click on building analysis. So the program is going to the building analysis is going to start. So I advise you not to interrupt this process.
We can't hear you, Mr. Kingsley. I think we need to check. Um,
Can everyone hear me? Can anyone hear me?
Yes, we can hear you. But then your screen is blank just now.
Please, can you guys see my screen?
Yes, we can see
Yeah,
your screen
we
now.
can see your screen.
Okay. Okay, thank you. Okay, so let's proceed. So we have completed our analysis and design. So what we can simply do is to um, look at our analytical model. Okay. Okay. Okay, now to look at that, what you can simply do is go to your views tab here, and you're going to see this option that says um analytical model. Okay, simply click on that in order to see your analytical model. Let's wait for it to come up. Yeah, okay. Okay, so this is the analytical model of the building that we have now designed. Okay, so these blue lines here are simply the um, frame wireframe elements of our members. Okay, so and the red lines here are simply the displacement diagrams or displacement members. Okay, so you can explore this. You can explore this as you would want. You can choose to turn on or off the different stories that you want to be showing alone. So let's just simply allow all the stories to be shown. So you can go through all this and know the different um, values of this of the I mean the different displacement values of your members. Okay, so you can go through that if you want all this here. So in our advanced classes, we are going to be explaining all this slowly in depth. Okay, the different displacement values, how to know which one is the shear force and the moment diagrams and all that, and we are going to be explaining that so that you can understand that better. Okay, for want of our time, we are going to be proceeding. So let me go back to the 3D view. Okay, so now let us now turn on our visual interrogation to check which members has now actually passed the design. To do that, go to the display tab and then click on visual interrogation. Click on that once and then go down here to design and then click on design status and then say okay. So when you have done that, you are going to see the design status of our building. So you can notice here from this particular design status by the left side of the modeling area, red means failure, yellow means warning, orange means expired analysis, green means okay. Then we have this one, do not design and not designed as well. So you are going to notice that our columns here are actually showing the red column, which simply means that they have not successfully passed the design. Okay, so what we are now supposed to do is to redesign these particular failed members. You are going to see other members that are green in color, which simply means that they successfully passed the design. But you are going to notice that what failed is most of our columns. Okay, but most of our beams actually passed the design. Okay, so now we have now covered the we have now covered this option, the first agenda, pre-analysis, building analysis. So we're now going to look at designs and then part foundations. Okay, so now let's go back to our structure. So now interactive designs. Once you have finished running your analysis, what you can now simply do is go to the design tab and then click on columns. So these are the various design tabs for your different members. You have columns, you have story beams, rib beams, foundation beams, and part foundation, bicaps, and all that. So I'm simply going to select columns and now let's run a batch design for our columns. So click on that and wait for it to come up. Give me a minute, please.
Kingsley, we can't hear you. Your screen too. We can't see your screen.
All right, can you hear me? Can you hear me?
Yes, we can hear you now.
Please give me a minute. Give me a minute, please. Let me correct something. All right. I believe you can now see my screen now. Okay, I believe you can now see my screen. I'm sorry
Yes, we
about
can
that.
see your screen now.
Sorry about that. Okay. So moving on, when you have now clicked on that, simply click on your columns design. Okay, you are going to get this this design column reinforcement design option. Okay, so now you are going to simply click on column batch design. When you have clicked on that, just say calculate. Select use here when previous are insufficient. So when you check this option, it is going to automatically redesign all the bars once. Okay, check it and then say calculate. Then
It's
give
live
it
class
some.
for real now. Live class. Yes, it's the audio I and since is muted, that's why. Data kan ló ń run. Fóònù inú ẹ̀kọ́ Yes, now it's a software. It will bring the light.
Okay, so when you have finished doing that, click on close, then close this door. Now let's look at the visual interrogation. Okay, now we are going to be getting, we are going to now see members that have now actually passed the design. Click on design status. We are going to notice some of our members are still passing design. Now this is how to correct them. Now simply go back to your model, to your design tab, click on that column design. So you are going to see get the list of all your columns. You can maximize this. Okay, so now this is simply the level of your columns, and here is story. This simply tells you the stories where this
Susan, your audio is
okay, so this is simply the stories. This is simply the stories where the columns are located, and here is just the sizes of your columns, and here is the design status. Please mute yourself, mute yourself.
Give us praise and worship. Just few songs. All the glory must be to the Lord. Okay, ó máa gbọ́n prayer ṣá máa sọ fún mi.
Okay, So when you have now done that, okay, so here's the design status. All these ones that have green check mark on them simply tells you that your that particular column has now passed design, and this one that has red cross means that they didn't pass the design. And here is the steel bar utilization ratio, and here is the quantity of steel that is supplied in percentage, and here the steel bar. So for these ones that now failed the design, okay, what you can now do to correct them is simply select that and then click on interactive design, or double click it, double click on that particular column, or let me just say interactive design. Okay, so when you click on that interactive design, you are going to get the interactive design panel or dialog. Here we have a little bit of detailing for the column that you have just designed. Here's the links and the reinforcement, and here we have the B1, B2, and B1, that is the breadth, the length and width of the column section. And simply click on interactive design, click on that, so that you are going to find out why that column is failing. It says here, warning, steel bar cannot be selected, section size is insufficient. Okay, what that simply means is that the size of that particular column is small, is not sufficient enough to sustain the loadings that is coming on that area. So simply say okay. Now to correct that, you're going to change, what you can do is to change the size of that column. Come here that says B2 and then B3, then change the size. So let's assume 250. 250. Okay, and then say update. Now go back to interactive design, click on it again so that you can see what is happening. Steel bar cannot be selected, section size is insufficient. So let us now keep increasing it. So let's go as high as 300 by 300. So you are going to do this thing for you're going to repeat this process for all of your columns that are failing, okay, until they finally start passing design. Okay, now it says reinforcement 4H12, and here is the area of steel provided and the percentage of that. Then say okay, this simply means that it has now successfully passed design. Okay, so when you say okay, you are now going to find out that the new breadth, length, and width of your column is now going to be 300 by 300, and here is the reinforcement, a little bit of reinforcement details of that column. And when you have now finished doing that, make sure you click on OK. So it tells you that the following analysis result will be invalidated if you proceed. Say yes. Can anyone hear me? Can anyone hear me? I noticed that
Yes,
the
we can.
network is
Yes, we can hear you, sir.
okay. Sorry about that. So I don't know. I didn't know how long I was offline. So can anyone tell me what I said last or where I stopped? Okay. So what did I say last or where did I stop? Nobody. Okay. So we are going to continue. So let me share my screen again. Okay, so if you can see my screen, this is where we are at. So we have now successfully finished designing that column that was failing, which is this particular column. Okay, and we have now also done so for this other column that is here. Okay, so you are supposed to do the same thing for all the columns that are failing here before you now start printing them or before you now move to your foundations. Okay, so now having done that, you can now close this up. Okay, so when you finish doing that, you still need to rerun your analysis. You can see that our design status is now telling us that our building analysis um is expired. This orange option. Okay, so what you simply need to do is go back to your analysis, building analysis, and then go to your analysis tab and then rerun your analysis again. Okay, so you have to repeat the same process after that. Okay, so for now we are going to be moving on. So you can turn off this visual interrogation, the design status of that. Okay, so that I have that like that. Okay, now so we have now successfully covered this option, design and interactive design. So I don't know how everyone was following because I started experiencing some serious network issues and my software was turning off. I don't know why. Okay, so let's move on. So after that, what we are going to be going to next is pad foundation design. Okay, so we are going to do that quickly. It doesn't really take time. Okay, so let's now go back to our story plan view, to our plan view. Now in our plan view, let's go to our story 00. That is where your foundation models can be, your foundation elements can be modeled. You cannot model your foundation elements in any of the stories that is not your story 0 level. Okay, so that is the only place you can model your foundation elements. Now, to add your pad foundations, to add your pad footings, what you simply need to do is that select a particular column, click on that, and then you're going to see this option that says insert pad footing. Okay, it's not here, but yeah, insert pad footing. You can click on that, or you can right click and say insert pad footing. Just click on that. So when you have clicked on that, you're going to get the pad footing design option. Okay, someone said he can't see my screen.